Good morning, 8th grade math students, and welcome to virtual math class. Today we are going to be talking about comparing functions. We will not be talking about interpreting functions in this video. I will save that for another video. And our objective for today is that students will be able to compare functions using the rate of change and the initial value. And remember that the rate of change is the same thing as the slope, and the initial value is the same thing as the y-intercept. So really, we know how to do this already. It's just kind of taking it one step further, and we're going to compare them with functions that are represented in different ways. So for this first example, we have function A and function B are linear functions. Remember that if it's linear, that means it has a constant rate of change. So the first question is, what is the rate of change of function A? So I look at function A, it is represented by the table. So to find the rate of change from a table, remember that it is the change in y over the change in x. So I look at how y is changing. How do I get from 2 to 14? That is plus 12. And how do I get from -1 to 5? That is plus 6. So then my change in y is 12. My change in x is 6. And if I do 12 divided by 6, that equals 2. So the rate of change of function A would be 2. Now, for function B, this equation is in slope-intercept form, which is y equals mx plus b. Remember that for the rate of change, that's the same thing as slope, and that is m, right? So what is in the place of m right now? So what's in the place of m would be 1, because if I have x by itself, anytime that I have x by itself, there's a 1 there. So which function has the greater rate of change? Is 2 bigger or is 1 bigger? 2 is. So function A would have a greater rate of change than function B. I forgot the A. There we go, function A. For our next example, I'm again asked about the rate of change. And again, it tells me that both functions are linear. So to find the rate of change from a graph, remember that I need to find 2 points. It doesn't matter what 2 points, it just has to be 2 points that I know exactly what they are. So after I find the 2 points that I know what they are, this point right here, I know that it is 2 and 0, and this point I know would be 3 and 2. So then I do my rise over my run. So how many do I rise? I rise 2, and how much do I run? 1. I do my vertical distance over my horizontal distance. So if my slope is 2 over 1, or my rate of change, 2 divided by 1 is just 2. So the rate of change for function A is going to be 2. Now for a table, remember I do the change in y over the change in x. So I look at how my y is changing. How do I get from -18 to positive 12? -18 to positive 12, I'm adding, and how much am I adding? I'm adding 30 here. So my change in y is going to be 30. And then what is my change in x? How do I get from -4 to positive 2? I know that I'm increasing, so I'm going to be adding. And from -4 to positive 2, that would be positive 6. So my rate of change is 30 over 6. And if I divide that out, 30 divided by 6 is going to equal 5. So my rate of change for function B is 5. So now my last question, which function has the greater rate of change? Function B does. So my answer is function B because 5 is bigger than 2. Our next example, notice on this question, I'm now asked about the initial value of a function. So remember that for the initial value of a graph, that is where x equals 0 because it's the same thing as my y-intercept. So I go to 0 on my x-axis. That is right here, 0. And where am I at on my y-axis whenever x is 0? I'm down here, right here. What point is that? Where does this line cross the y-axis at? It's between -4 and -6. So I know -5 is between there. So my initial value for function A is going to be -5. Now, whenever I'm given an equation, remember the equation is given to me in slope-intercept form, which is y equals mx plus b, where m is my slope or my rate of change, and b is my y-intercept. So the number with x is our slope. So in this case, 3 is going to be our slope. And then what is in the spot of plus b do I have anything there? No. So if I have nothing there, what is my initial value going to be? 0. So now, which function has the greater initial value? Is -5 bigger or is 0 bigger? Would you rather break even and be 0, or would you rather owe someone $5? Break even, right? 0 is bigger than a negative number. So function B would have a greater initial value than function A. In our last example, I'm again asked about the initial value. So looking at function A, again, I find where x equals 0, and I find where it touches the line at. It touches right there. What number is that? That is -4. So it crosses my y-axis. Remember, that's my vertical axis at -4. Now, to find the initial value from a function, the first thing that I'm going to do is I'm going to find my rate of change. So I look at my change in y over my change in x. From -20 to 10, that is adding 30, right? So my rate of change would be, or my change in y is going to be 30. My change in x, I go from -4 to +2, and that would be +6. And 30 divided by 6 is going to be 5. So m, or my rate of change, is 5. Now, I'm going to use my slope-intercept form of y equals mx plus b. Now, to figure out what x and y is going to be, I'm simply going to choose a point from the table. I'm just going to choose 210 because it's low numbers and they're positive. So if that's the case, my y value is 10. So I plug in 10 for y. M, I already found, was 5. X, I go back to my table. 2 is in the x value spot. And then my plus b, that's what I'm trying to figure out. So I'm going to just leave that as plus b. So now I'm going to solve this equation. The first thing that I have to do is I have to do 5 times 2. 5 times 2 equals 10. And then I bring down my plus b. And now this is a simple one-step equation. 10 plus what equals 10? Or I can subtract 10 from both sides because I have to do the opposite to get rid of it so I can get b by itself. So then I'm left with b on this side, and 10 minus 10 is 0. So my y-intercept in this case is going to be 0. So now which one is bigger, -4 or 0? Function A or function B? Function B is going to have a greater initial value because 0 is bigger than -4.